Imagine looking up at the night sky and seeing a massive planet hurtling toward us, unstoppable, unavoidable, and ready to end life as we know it. No warning, no way to stop it, just a countdown to catastrophe. Sounds like science fiction, right? But rogue planets, wandering, homeless worlds drifting through space, are very real. And if one were on a collision course with Earth, what would happen? Could we survive? Could we stop it? Buckle up, because we're about to dive into one of the most terrifying what-if scenarios in cosmic history. Let's find out. What is a rogue planet? Imagine a planet drifting alone through the cold, endless void of space. No sun to warm it, no orbit to follow, just a cosmic wanderer lost in the abyss. These are rogue planets, the mysterious loners of the universe. Unlike Earth, which faithfully orbits the sun, rogue planets have no home, no system, no star to call their own. They roam freely through the galaxy, traveling at mind-blowing speeds, completely untethered to anything. But how do these planets become rogue in the first place? Some of them start out like normal planets, forming around a star just like Earth, Jupiter, or Mars. But then, something goes terribly wrong. A massive cosmic event like a nearby supernova explosion, a close encounter with a larger planet, or a gravitational slingshot from its own sun kicks them out of their solar system entirely. Imagine Earth suddenly getting thrown out of the solar system and flung into the dark unknown. Terrifying, right? Other rogue planets may have never belonged to a solar system at all. Some astronomers believe they could have formed directly from swirling gas and dust in deep space, much like stars, but without enough mass to ignite into a sun. That means these planets were born as wanderers, destined to forever drift through the coldest, darkest regions of space. And here's the real kicker. Scientists believe there could be billions, if not trillions, of these planets in our galaxy alone. Some may be small and frozen like Pluto, others could be massive gas giants even bigger than Jupiter, but the biggest question is, could one of them be heading toward Earth right now? How likely is a collision with Earth? Alright, let's get to the real question. Could a rogue planet actually collide with Earth? I mean, space is massive, but with billions of these wanderers floating around, isn't it just a matter of time before one crosses our path? Well, here's the good news. The chances of that happening are ridiculously low. Space isn't just big, it's mind-blowingly, impossibly, absurdly huge. Even within our own solar system, planets are separated by millions, sometimes billions of miles. Now, imagine trying to hit a specific grain of sand on a beach by throwing another grain of sand from a mile away. That's how unlikely it is for a rogue planet to randomly collide with Earth. But the odds aren't zero. If a rogue planet were to drift close enough to our solar system, things could get messy, even if it doesn't hit Earth directly. Why? Because gravity is a cosmic troublemaker. A massive rogue planet passing near us could disrupt planetary orbits, pull asteroids out of the asteroid belt, or even mess with Earth's own path around the sun. Now here's a terrifying thought. What if a rogue planet entered our solar system and got stuck? Instead of a direct impact, it could settle into a highly unstable orbit, causing long-term chaos. Imagine Earth suddenly shifting its orbit just slightly. That could mean extreme climate changes, rising sea levels, and devastating natural disasters. So, while an actual impact is insanely unlikely, a near miss could still be catastrophic. And with billions of rogue planets out there, the question isn't just if one will pass by, but when. What would happen before the impact? What if a rogue planet is headed straight for Earth? But before it smashes into us like a cosmic wrecking ball, we'd see the warning signs, and trust me, they wouldn't be subtle. First, astronomers would spot it months or even years in advance. At first, it would just be a tiny speck in the night sky, barely noticeable. But as it barreled toward us at breakneck speed, that speck would grow brighter, bigger, and way more terrifying. Scientists would be scrambling to calculate its trajectory, hoping, praying that it might miss us. Then, the real chaos begins. As the rogue planet gets closer, its gravity would start messing with Earth. The oceans would rise and fall in unpredictable ways, triggering devastating tsunamis and floods. The moon, our trusty sidekick, could be pulled into a slightly different orbit, throwing off tides, weather patterns, and maybe even Earth's rotation. But it doesn't stop there. The rogue planet's gravitational pull could ignite a wave of earthquakes and volcanic eruptions worldwide. The sky might start to change color due to atmospheric disturbances, and some areas could experience violent, unpredictable storms. Imagine lightning storms stretching for miles with hurricane-force winds tearing through cities long before the planet even arrives. And as it gets even closer, all eyes would be on the sky. It would dominate the horizon, a massive looming shadow glowing eerily from reflected sunlight. At this point, there would be no escape, no way to stop it. The only thing left, brace for impact. The moment of collision. This is it, the moment everything changes. The rogue planet has arrived and there's no stopping it, no escape, no second chances. The only thing left to do is watch the sky and pray. As the planet enters Earth's atmosphere, it's moving at tens of thousands of miles per hour, faster than any bullet, faster than anything humans have ever seen. The sky ignites as a fireball larger than entire continents blazes through the heavens. The atmosphere superheats in seconds, turning the very air into a weapon. Winds stronger than any hurricane rip through cities, flattening everything in their path before the impact even happens. Then, the unthinkable. The rogue planet slams into Earth with unimaginable force, unleashing an explosion millions of times stronger than the asteroid that wiped out the dinosaurs. The shockwave alone incinerates everything within thousands of miles. Mountains vaporize, oceans boil away instantly, skyscrapers crumble to dust before they even hit the ground. And then comes the second wave of destruction. A mega tsunami, thousands of feet high, crashes across continents, swallowing entire countries. A global earthquake shakes the planet's core, causing volcanoes to erupt simultaneously across the world. The Earth itself cracks apart, sending molten rock and debris into space. And just when it seems like things can't get worse, they do. The entire sky goes dark. Ash and debris fill the atmosphere, blocking out the sun for years, maybe even centuries. Temperatures plummet. The world is left in an endless winter, a dead, frozen wasteland. Could humanity survive? Let's be honest, surviving a direct collision with a rogue planet? Nearly impossible. But what about after the impact? Could anyone, anything, make it through the ultimate extinction event? First off, if you were anywhere near ground zero, there's no chance. The impact would have vaporized everything instantly. People, buildings, entire cities, gone in the blink of an eye. But what about those in deep underground bunkers, nuclear silos, or submarines at the bottom of the ocean? They might survive for a while. But then comes the long-term nightmare. The sky is now choked with ash and debris, blocking the sun for years, maybe centuries. With no sunlight, plants die. Without plants, the entire food chain collapses. Temperatures plummet, turning Earth into a frozen, lifeless wasteland. No crops, no animals, no fresh air. The world becomes a graveyard of ice and fire. But humans are resilient. Some small groups might make it, relying on underground farms, stockpiled food, or geothermal energy. Maybe a handful of scientists, billionaires, or government officials sealed away in hidden bunkers would survive, watching the dead world above from their screens. And then there's one final possibility, leaving Earth entirely. If we had enough time, could we have escaped? Built a colony on the moon, Mars, a space station floating above the disaster? Right now, we're nowhere near prepared. But in the future, maybe. So could humanity survive? A few might. But the world we once knew, that would be gone forever. Can we prevent this? We've talked about what happens if a rogue planet collides with Earth. But here's the real question. Can we actually stop it? Can humanity pull off the ultimate sci-fi rescue mission and prevent total annihilation? Well, not really, at least not yet. Unlike asteroids, which we have plans to deflect using nuclear explosions or kinetic impactors, a planet-sized object is on a completely different level. You can't just blow up a planet like in the movies. Not even with every nuclear bomb on Earth. It would be like throwing a firecracker at a freight train and hoping it stops. So, what's the alternative? Deflection. If we spotted a rogue planet early enough, we're talking decades or even centuries in advance, we might have time to alter its trajectory. Some scientists have theorized using gravitational tractors, huge spacecraft that hover near the planet and slowly pull it off course using gravity. Sounds cool, but it would take massive amounts of time and energy. Time we probably wouldn't have. Another idea? Building a fleet of planet-sized rockets to push Earth out of the way. Yes, you read that right. Instead of stopping the rogue planet, we move Earth itself. Sound insane? Well, scientists have actually proposed using massive nuclear pulse propulsion to shift Earth's orbit if we ever faced a cosmic disaster. Wild, right? But let's be real. With today's technology, we'd be helpless. Our best hope? Detect the threat early enough to evacuate Earth. And that means colonizing Mars, the Moon, or even space stations before it's too late. So, can we prevent it? Not now, maybe not ever. But if humanity wants to survive the next billion years, we better start thinking big. So, could a rogue planet really collide with Earth? Highly unlikely, but not impossible. And if it ever happened, the results would be catastrophic beyond imagination. Right now, we don't have the technology to stop it, but who knows? The future of space exploration might hold the key to saving our planet. If you love mind-blowing space theories and futuristic tech, make sure to subscribe to InnoVision Tech. Stay curious, stay prepared, and I'll see you in the next video. Until then, keep exploring the unknown. Imagine looking up at the night sky, seeing endless stars, and realizing we know almost nothing about what's really out there. The universe is vast, mysterious, and terrifying, hiding secrets that could change everything we think we know. What if reality isn't real? What if something dangerous is lurking in the dark, watching us? Today, we're diving into the creepiest space theories that might actually be true, ideas so unsettling, they'll make you question your place in the cosmos. Buckle up, because after this you might never look at the universe the same way again. Ready? Let's begin. The false vacuum universe. Imagine the universe as a giant peaceful bubble floating in an endless cosmic ocean. Everything we know, galaxies, stars, planets, and even us, exists inside this bubble. But what if I told you this bubble isn't as stable as we think? According to the false vacuum universe theory, our universe might just be a temporary, low-energy state, a false vacuum. And at any moment, without warning, it could pop. Here's how it works. If somewhere in the vast cosmos a tiny quantum event triggers the transition from this false vacuum to a more stable true vacuum, an invisible wave of destruction would expand at the speed of light. It wouldn't be an explosion, it wouldn't burn or shatter things, it would rewrite the very fabric of reality. Imagine flipping a light switch, and suddenly the laws of physics are completely different. The atoms in your body, gone. The stars, erased. The entire universe as we know it, vanished. The most terrifying part? If this process has already started somewhere, we'd never see it coming. It wouldn't send a warning, no flashing red lights, it would just happen. Scientists believe this is unlikely, but hey, the universe doesn't exactly send out newsletters to let us know when it's planning something big. So, could we be living on borrowed time? The truth is we don't know. But if one day everything just blinks out of existence, well, guess we'll have our answer. The Great Filter. Alright, let's talk about something that has been haunting scientists for decades. Where are all the aliens? Think about it, the universe is massive. There are billions of galaxies, each with billions of stars surrounded by countless planets. Statistically, there should be millions of advanced civilizations out there, and yet, nothing. No signals, no spaceships, no cosmic neighbors stopping by for a chat. This eerie silence is called the Fermi paradox, and the Great Filter might be the answer. The theory suggests that somewhere in the timeline of life's evolution, there's an almost impossible barrier that stops civilizations from advancing. Maybe life rarely starts in the first place. Maybe simple bacteria can exist, but complex, intelligent beings like us are incredibly rare. Or maybe, just maybe, every civilization that gets advanced enough eventually destroys itself. Nuclear war, climate catastrophe, rogue AI, pick your apocalypse. If the Great Filter is ahead of us, that means humanity hasn't reached this dangerous turning point yet, but it's coming. And if history tells us anything, we're not exactly great at avoiding self-destruction. If the filter is behind us, well, that means we're one of the very few civilizations to ever make it this far. So, the real question is, are we special, or are we doomed? The dark forest hypothesis. Picture this. You're walking through a dense, dark forest at night. It's silent. Too silent. You know that dangerous predators could be lurking, hidden in the shadows. Do you call out to see if anyone is there? No, because if you make a sound, you might be the next thing to disappear. Now, apply this to the universe. This is the dark forest hypothesis, a terrifying explanation for why we haven't found any alien civilizations yet. It suggests that the universe is like a dark forest filled with intelligent civilizations, but everyone is hiding, because making your presence known could be a death sentence. Think about it. If alien life exists, It's possible that advanced civilizations view any unknown life as a potential threat. And in a universe where the strong prey on the weak, the safest move is to eliminate others before they eliminate you. It's the ultimate survival strategy. Stay silent, stay hidden, and never trust anything that moves. So what does this mean for us? Well, we've already shouted our presence into the void. For decades we've been broadcasting signals, launching messages into space, basically announcing, hey, we're here. If the dark forest hypothesis is true, that could be the biggest mistake we've ever made. What if something far more advanced, is out there listening? What if it's already on its way? Maybe, just maybe. The reason we hear nothing from the cosmos isn't because no one's there, it's because the ones who spoke up aren't around anymore. The Berserker Hypothesis. Imagine an ancient, advanced civilization, one so powerful that it no longer needs to conquer planets in person. Instead, it builds self-replicating machines, ruthless AI-driven probes designed to seek and destroy any emerging intelligent life before it becomes a threat. These are called berserkers, and according to the Berserker Hypothesis, they could already be out there. The idea is simple. Long ago, a hyper-advanced civilization could have sent out killer machines into the cosmos with one goal: eliminate all potential competition before it rises. These berserkers might roam the universe scanning for signs of intelligent life, waiting for a signal that confirms a planet is inhabited. And once they detect it, they wipe it out. No negotiations, no mercy. Now let's consider Earth. We've been broadcasting our existence for decades: radio signals, satellite transmissions, even messages deliberately sent into deep space. If berserkers exist, they might have already heard us. What if that's why the universe is so silent? Maybe civilizations rise, send out their signals, and shortly after disappear. So what's stopping these berserkers from reaching us? Maybe nothing. Maybe they're already on their way. Or maybe they're already here. The holographic universe. What if I told you that everything you see, feel, and experience, your entire existence, isn't actually real? That you, me, the Earth, and the vast universe itself might just be a hologram. Sounds insane, right? Well, some scientists believe it's possible. The holographic universe theory suggests that our entire reality might be nothing more than a projection from a two-dimensional surface. Imagine a movie playing on a screen. Characters, depth, and motion all appear real, but they're just an illusion of light and information. According to this theory, our three-dimensional universe is a cosmic version of that movie where everything we experience is just a shadow of deeper physics we can't even perceive. And here's where things get creepy. Some evidence actually supports this idea. Scientists studying black holes found that all the information about what falls into them can be stored on their surface, not inside, just like a hologram. If this applies to black holes, what if the entire universe works the same way? Even weirder, quantum physics suggests that the universe is pixelated at the smallest scale, like a digital simulation. If that's true, then we might just be data running on some unfathomable cosmic system. If someone, or something, is running the program, would we even know? Or worse, what happens if they decide to pull the plug? The space animal hypothesis. For decades, people have reported unexplained objects in the sky, things that don't behave like normal aircraft or meteors. But what if some UFOs aren't alien ships at all? What if they're living creatures? The space animal hypothesis suggests that some of the strange things we see in the sky, blurry, shape-shifting objects moving in impossible ways, aren't spacecraft, but undiscovered life forms that exist in the upper atmosphere or even deep space. Think about Earth. We once believed nothing could survive in the deepest oceans, yet we found bizarre creatures thriving in extreme conditions. So why couldn't there be creatures adapted to living in space? Instead of flesh and blood, they might be made of plasma, or electromagnetic fields, floating undetected in the upper layers of our atmosphere, or gliding through the vacuum of space. If this is true, then maybe we're not just exploring space, we're intruding on someone else's home. And if these creatures are watching us, studying us, or even interacting in ways we can't yet understand, the real question is, are they friendly? Or are they just waiting for the right moment to let us know they're here? The universe is full of mysteries, some we may never understand, and others we might wish we never discovered. Are we alone, or are we just one signal away from something finding us? Let me know what you think in the comments. If you enjoyed this deep dive into the creepiest space theories, don't forget to like, subscribe, and hit the bell so you never miss a mind-blowing video. This is InnoVision Tech, bringing you the future, one theory at a time. See you in the next one, if the universe doesn't reset us first. Imagine stepping into a spaceship, firing up the engines, and blasting off at the speed of light. What would happen to your body? Would time slow down? Would you even survive the trip? Science says it's way more bizarre than you think. From time travel to your own body stretching like spaghetti, light-speed travel is both mind-blowing and terrifying. But here's the big question. If you had the chance to travel at light speed, would you take it? Or would the dangers be too much? Let's break it all down. Buckle up because this ride is going to warp your mind. Time dilation. Imagine you hop into a futuristic spacecraft and accelerate toward the speed of light. From your perspective, everything inside the ship feels normal. You're still breathing, moving, and maybe even scrolling through your favorite playlist. But to someone watching from Earth, your movement slows down drastically. Your seconds stretch into minutes, hours, even years. This isn't science fiction, it's time dilation, predicted by Einstein's theory of relativity. If you were moving at 99.99% the speed of light, time for you would be crawling while the rest of the universe speeds ahead. Let's say you embarked on a 5-year journey at this speed. When you return, Earth might have aged hundreds or even thousands of years. You'd be a time traveler, just not in the way Hollywood imagines. But here's where it gets mind-blowing. If you actually hit the speed of light, which, by the way, is physically impossible for objects with mass, time for you would completely stop. You'd be frozen in a timeless state while the universe ages infinitely around you. You could witness the death of the sun, the rise and fall of civilizations, and the slow drift of galaxies, all in what feels like an instant. Crazy, right? But here's a question for you. If you had the chance to experience this, would you? Let me know in the comments. Mass increase. Now let's talk about something even wilder. What happens to your body as you push closer to light speed? According to Einstein's equations, your mass starts increasing. Not by a little, but exponentially. Let's say you weigh 70 kilograms. At 50% of the speed of light, your mass would be around 100 kilograms. At 90% of light speed, your mass would be more than double your normal weight. But if you somehow reached 99.9999% of light speed, your mass would shoot up to thousands or even millions of kilograms. Why does this happen? Because as you go faster, your energy turns into mass. And the closer you get to light speed, the more energy you need to keep accelerating. At exactly light speed, your mass would be infinite, which means you'd need infinite energy to keep going. And guess what? The universe doesn't have that much energy to spare. So even if we had the most advanced spaceship ever, no physical object with mass could ever hit light speed. Nature itself puts a speed limit on us. But what if we could bend the rules with a warp drive? Would that be the ultimate loophole? Stick around. We'll explore that soon. Which do you think is crazier, becoming infinitely heavy or traveling through time? Drop your thoughts in the comments. Visual distortions. Alright, let's get into something mind-bending. What would you actually see if you were traveling at the speed of light? Spoiler alert, it wouldn't be a normal view out the window. First off, your entire field of vision would warp into a tunnel right in front of you. Everything that was once around you, stars, galaxies, planets, would squeeze toward a single point. It's called relativistic aberration, and it happens because of how light waves shift when you're moving ridiculously fast. But here's the real kicker. The colors of everything would start to change. Objects in front of you would turn intensely blue shift, while everything behind you would fade into deep red or even disappear into darkness. Imagine flying through space and seeing stars melt into streaks of white and blue, like a scene from a sci-fi movie, except this is real physics. And let's not forget the Doppler effect, a bizarre phenomenon that would make invisible radiation suddenly visible. Normally, space is full of harmless microwave radiation, but at near light speeds, those microwaves would shift into dangerous X-rays and gamma rays. In other words, your spaceship would be bombarded with deadly radiation, and without extreme shielding, you'd be fried in an instant. So, even if we found a way to break the light speed limit, surviving the cosmic light show would be a challenge on its own. But what about the shape of your spaceship? That brings us to our next crazy effect, length contraction. Length contraction. Here's something that will completely mess with your perception of reality. The faster you go, the shorter everything gets, including you, your spaceship, and even the distance you're traveling. Let's say you want to visit Proxima Centauri. the closest star to Earth about 4.2 light-years away. Normally that's an insanely long trip, but at 99.99% of light speed, something incredible happens. The distance shrinks dramatically from your perspective. Instead of 4.2 light-years, it might feel like a few months or even weeks of travel time. But hold up, it's not just space that contracts. Your spaceship would actually become thinner in the direction you're traveling. If it's 100 meters long when standing still, it might shrink to just a few meters when moving near light speed. And you? To outside observers, your entire body would flatten like a pancake. You wouldn't feel it happening, but someone watching you from Earth would see you squashed beyond recognition. This is called Lorentz contraction, and it's not some sci-fi concept. It's been proven with high-speed particle experiments. We've seen tiny particles like muons, which should decay in microseconds, last much longer because of time dilation. And they actually appear squished when observed at near light speeds. So if you ever dream of traveling at light speed, get ready for a very distorted universe, shrinking spaceships, and your own body compressing like a sci-fi horror scene. Question is, would you still want to experience it? Let me know in the comments. Causality violations. Alright, now things are about to get seriously weird. If you could somehow move at or faster than light speed, you wouldn't just be traveling fast, you'd be messing with time itself. And I don't mean just time slowing down like in time dilation, I mean full-blown causality violations where effects could happen before their causes. Think about this. Normally if you drop a glass it shatters, right? Cause and effect. But at light speed, weird things could start happening, like seeing the glass already shattered before you even dropped it. In extreme cases, traveling faster than light could mean arriving somewhere before you even left. Sounds impossible? Well, that's exactly why Einstein's theory of relativity says nothing with mass can exceed the speed of light, because it would throw our entire understanding of time and reality into chaos. If information or objects could travel faster than light, it could theoretically create closed time loops where an event causes itself. That's how we get paradoxes like the famous grandfather paradox where you could go back in time and accidentally prevent your own birth. But here's where it gets even stranger. Some scientists believe that if faster-than-light travel were somehow possible, it might only be possible in specific directions, meaning you could go forward but not backward, or only to certain points in space-time. Sounds complicated, right? So, even if we somehow built a spaceship that could break light speed, we'd have to deal with the fact that time itself might stop making sense. Would that mean accidentally opening doors to the past, creating alternate timelines, or something even crazier we haven't imagined yet? Let me know what you think. Would you risk breaking time itself just to see what happens? The infinite energy problem. Alright, let's get to the final and biggest problem, the reason we will probably never reach light speed. It all comes down to one brutal truth: you'd need infinite energy. Here's why. As you get closer to the speed of light, your mass increases exponentially. That means it takes more and more energy just to push you a little bit faster. At 99.99% of light speed, you'd need more energy than the entire Earth's yearly energy output just to gain a tiny bit more speed. And to actually hit 100% light speed, you'd need infinite energy. But here's the thing, our universe doesn't have infinite energy. Even if we could harness all the energy from the sun, all the black holes and all the dark matter combined, it still wouldn't be enough. This is why no object with mass can ever hit light speed. The laws of physics just don't allow it. Photons, the particles of light, are the only things that can travel at light speed because they have zero mass. Everything else? Stuck at sublight speeds forever. So, does that mean faster than light travel is completely hopeless? Not necessarily. Scientists are looking into warp drives, wormholes, and even quantum shortcuts that might allow us to cheat the system without actually breaking the speed limit. But whether any of that is possible, still up for debate. So let's hear it. If you had a chance to experience light speed travel, even with all these insane consequences, would you do it? Drop your thoughts below. So, after everything we've explored, would you still take the risk of traveling at light speed, or is it just a sci-fi dream that's better left untouched? Let me know in the comments. And if you enjoyed this mind-bending journey, don't forget to like, subscribe, and hit the bell icon so you never miss out on the next big tech and space adventure. This is InnoVision Tech, bringing the future to your screen. See you in the next one.